Hello, I've had a question in Unit 2, Lesson 4, number 68. So we have a police car that stopped at a set of lights. So what I'm going to do here is I'll set up, this is my location of my lights. Here's the police car. And we have a speeder that passes while that car is sitting there at 100 kilometers an hour. So my speeder, V equals 100 kilometers an hour, which I will convert to meters per second. So we get 27, let's call it 27.8 meters per second. The police car can accelerate, so I have police car information here. So I know its initial velocity. The initial velocity is 0 meters per second, and then they do tell us police car can accelerate at 3.6 meters per second squared. How long does it take to catch the speeder? Okay, so they're taking off at the same point in time here, so there's no delay. So in this case, the speeder can travel to this point when he's caught. So the police car is going to cover the same amount of distance. So we know this distance is uniform for both of them. So our delta D in this case is going to be x. We don't know how far it is, but it will be the same. And our time is also going to be the same for both the police car and the speeder. So using the speeder's information, so just going to kind of do some cleanup here. So we will group, shrink that down. Okay, so for the speeder, because it's moving at a constant velocity, D equals VT. We can regain some motor skills here. There we go. So I know delta D is x. That's how far they're traveling. Velocity is 27.8 times time. I have two unknowns in this one equation, so I can't go any further. If I look at my police car, I'm going to have to use this particular formula because I know velocity and time. So again, travels x meters. V1 is 0. So it makes that value go to 0. 1/2 3.6 t squared. That should be a 6. X equals 1.8 t squared. So now I have a second equation. So now I have two equations, two unknowns. However, x is equal to each other. So if we sub 1 into 2, we know that 27.8 t equals 1.8 t squared. So we need to move them to the same side. 1.8 t squared minus the 27.8 t. Don't divide out that t because it is a valid answer. Or sorry, don't cancel out a t. We're going to factor out a t. Actually, I'm going to pull out a 1.8 t, leaving me with t minus and the 27.8 divided by 1.8 gives me 15.4. So from your grade 10 math, the only way that this is true is if t equals 0 or t equals 15.4 seconds. So therefore, the police catch the speeder after 15.4 seconds. B part, how far does the police car have to go? So we can use this formula right here because we're just calculating x. So for B part, x equals the 1.8 t squared, 1.8 times 15.4 squared. So 1.8 times 15.4 squared gives me, let's call it 427 meters. Therefore, and the last one, what would its speed be when it caught up to the car? So we're looking for our V final. So V2 equals V1 plus AT. So V2 is what we're looking for. V1 was 0. Accelerated at 3.6. Traveling for 15.4 seconds. 3.6 times 15.4 is 55.4 meters per second. And to put that into kilometers per hour, that's almost 200 kilometers an hour. Probably unreasonable that the police car is going to be doing 200 kilometers an hour, just due to safety factor and the fact that that is fairly brisk. Car could probably do it, but wouldn't happen really in the real world. The only way this question can change is if there's been some lead time here. So sometimes the police officer doesn't start right away. Sometimes there's a 10-second lag. And if that's the case, then you figure out, for example, if the speeder was doing 27.8 and they had a 10-second lead, that means they've traveled 278 meters to this point. So if the speeder has to do X meters, the police car will have to do X plus 278 to catch up, which would then transfer over to this part of the formula. So you'd have to add the 278 on and then solve the equation accordingly. So if you have any questions with that, let me know, and I will clarify anything that you're getting confused with.